Hello again, this is Tom, your friendly calculus teacher, professor. Not a professor in college, but just certainly professor in programming the calculator. And calculus, actually, too. Studied calculus for 25 years. And it's, of course, Every Step Calculus and EveryStepPhysics.com as my sites, where you can buy these programs and load them into your Titanium. I'm the only one in the world that does it. So enjoy my programs and pass calculus. But anyways, this is the washer method. The reason you know it's a washer method is because there's two functions, okay, and rotating about something. And the reason you know it's around the x-axis is because there's an x, y is equal to x here. Otherwise they would have x equals to y. Okay, so this is x on the right side of the equation, y equals x cubed, so then it's going to be a dx problem with respect to x. And let's do it. Index 8 to get to my main menu. I'm already at washer method here. That's lucky. But you'd scroll to it with the cursor here. And of course you can press second and then use these cursor, which goes down a page, because this is 150 menu items here for your calculus needs. Greatest cheat sheet in the world. And we're going to volume of a solid with a washer method. Okay. And we're going to revolve around the x-axis. Here's the formula. Write that down in your test paper. You've got 2 points because everything is partial credit in the class curve. And is a number that y rotates around given? Yes, there is. Y equals -3, so we're going to say yes there, and we're going to enter it. Alpha -3. I'll show you what you've entered. You've entered it okay. Generally there are two y functions. A lot of times one is generally just a single number. You set them equal to each other and then you find the limits of what you're talking about. Here's the first equation we're going to enter. Alpha x cubed. Second one is alpha 1. Again, show you what you've entered. It's good. Press OK. Because the rotating was because the -3 was given, the Rx is going to be -3 minus the function, and the Rx is going to be -3 minus that function. Okay, and then we find out what x equals, etc. Just like you write this on your paper, exactly like you see it. Okay. We set the functions equal to each other, and it comes up with x equals 1. So that's the lower range right here in the integral, lower range. The value for x given, yes, x equals 2, alpha 2. And so here's our integral we're setting up, okay? Pi 1 over 1 and 2, okay? X cubed minus 3, what we computed before. We're going to square the terms, okay? It's just like this. We're going to integrate. And the limits are 2 and 1. At x equals 2, you're going to put 2 in for all these x values here. I have to use quotation marks because the calculator will only let me do that, and so you have to put parentheses around what you're entering in here, because here's x to the 7, which you're going to put parentheses around the 2 here because you're substituting 2 for x, okay? Turns out to be this, 198 pi over 7. And at x equals 1, you've substituted that into the equation for that. 1 equals minus 75 pi over 14. Upper minus lower turns out to be 471 pi over 14, or 33.6 cubic units, just like here. Notice people that answer these questions, this is just, they don't put cubic units, because even though it's supposedly a volume, who's gonna verify this? I don't even know if it's correct. I mean, if you really wanted to know and who wants to know the volume of this stuff anyways? But I mean, that's calculus, okay? So go to my site, buy my programs, and pass calculus. Have a good one, okay?